Traveler in summer heat, please rest your soul and feet in our goldfish pond. So in the last episode, we made this flock controller. From this episode, I'll be making the goldfish itself. But I'm splitting them into 3 episodes due to the sheer volume of notes to cover. In this episode, I'll be making the body mesh and its animation. So you might be asking, why use geometry nodes to make a mesh? Why not just model it in normal fashion? Well, the biggest reason is its controllability from geometry node. If you instance an object from Outliner, you basically have no control over its behavior during animation. Whereas if you make it with geometry nodes, you can control them through arguments. Also, it's just simply faster. In spare time, I make a lot of high poly goldfish models with animation, which I publish them to sites like Sketchfab. These models take roughly 10 to 20 hours going through the whole process from sculpting to animation. It's going to take days if I want to make a school of fish that way. With geometry nodes, though the first step might take a bit of getting used to, you can quickly mass produce a bunch of variations, which is perfect for generating flocks. So, let's start off by hiding the Bezier curve with flock controller attached. Then, Shift-A, add mesh plane. Create a brand new geometry node map with new, delete group input, then replace it with curve line. Change the end setting to 1, 0, 0, then output. Think of this curve as a fish's spine. Add a resample curve and change the mode to length. Then set the value to 0.05 meters to add more points. When making a mesh object with geometry nodes, I like to start off by visualizing animation before adding mesh. So let's start by adding a set position. Connect the offset to combine XYZ. Then connect sine to Y and spline parameter factor to sine. Sine wave is only partially visible, so let's add mass, multiply, and input tau. We can now see the full period, but since goldfish body doesn't fluctuate that much, let's reduce it to 3/4 of tau. The amplitude is also too strong, so insert a mass multiply after the sine. Multiply with 0.1 to bring it down. Next, we'll start adding some movement. Insert a mass add after this multiply. Then, connect it to scene time seconds. We can see the wave moving when we run the animation. Add a multiply to control the speed, and let's set the value to 5 for now. Insert an add here as well as initial offset so we can later add variations. Set this value at 0. If we consider the left side to be its head and right side to be its tail, we actually don't want the head moving this much. Let's connect another multiply to this bottom socket. Then input the original 0.1 to the bottom value and pull out a float curve from the top. Connect a spline parameter factor from the value socket. Then we can adjust the curve to a shape like this. Now the head is moving around less and is resembling more like a swimming fish. Let's grab these nodes and Ctrl-G to group them. Open up the side panel with N, then pull out a group input from this multiply. And rename the argument to movement speed. Do the same with add. Call it movement offset. Tap to exit out of the node group. Then rename it set body movement. Now, since we applied a wave on curve, curve is now a bit longer than original 1 meter. Let's trim it back down using trim curve and setting its mode to length. Next, we'll add a store named attribute on points to keep track of spline factor even after mesh conversion. Call it body fac. This attribute will be used in multiple areas later. Now, let's start generating body mesh. Add a curve to mesh. Then, use spiral for profile curve. For its parameters, use 16 for resolution, 1 for rotation, start and end radius, 0 for height to make it into a cylinder. Let's mute the set position so the spine becomes straight. Okay, it's a cylinder now. If we check the face orientation, normals are pointing inwards, so click on this reverse option to flip them around. Next, the seam of the spiral is visible on the side. So add a transform geometry and rotate 90 degrees on z-axis to bring it to the bottom. We will be unwrapping this UV, so use spiral and not circle. Now, we'll work on the shape appearing from above. First, add a set curve radius. Connect the mass multiply to radius, then input 0.3 for the top value. Connect the float curve to the bottom socket and spline parameter factor to its value. Let's adjust the curve until this cone looks like a long neck vase. If we move the leftmost point a little upwards, we can make an opening for a mouse. We always can make adjustments later, so no need to make it perfect now. Let's input 0.3 to the Y scale for this transform geometry to make it thinner. Now it resembles a fish from the top, and I hope yours do too. The top view is fine, but there's a lot to be desired from the side. So let's get started on shaping its profile. We need some trickery since fish is not symmetrical in Z direction. We'll start by branching a sample curve from store named attribute. Enable all curves, then connect the named attribute body fac to the factor socket. Next, add a position and using vector mass subtract the sampled position from it. Ctrl-Shift-D to duplicate with connections. Bring it down and change operation to distance. Connect a separate XYZ from subtract, then mass divide from Y. Divide the result with distance. Next, Take the absolute values and connect to mass subtract. Input 1 to the top and subtract the result of abs. Let's take a look with the viewer. This calculation results in value reduction, as y distance becomes farther away from the center curve. Okay, we'll start shaping the height profile. First, insert a set position here. Then, add a position node. Connect a separate XYZ from position, then combine XYZ. Connect only X and Y, then plug it into set position socket. It is now flat since Z is set to 0. Connect the Z to float curve and value to named attribute body fac. The curve is now showing up as Z value. Insert a mass multiply and enter a value of 0.2 to reduce the effect. Insert another multiply and connect the result of calculation we made earlier. The mesh now has shell-looking volume. Let's start adjusting the float curve to a desired shape. We can observe that the top of the shell is conforming to shape of the curve. Let's make the top half of fish. Tail fin is included, so make sure the right part resembles a fin. For the bottom half, we'll select these 4 nodes and Ctrl-Shift-D to duplicate with connections. Change the value of multiply to -0.2 to flip the Z direction. To connect these 2 halves, add a position node, then separate XYZ. From Z, connect a greater than, then switch node. Change the type to float. Plug in the top half result to true and bottom half result to false. Then, use the result as Z input for combine XYZ. Let's reorganize a bit. Then, make minor adjustments. As stated earlier, fish is not Z-symmetrical, so add subtle difference between top and bottom half. When you're satisfied with the result, select these nodes and group them with Ctrl-G. Reorganize again. Yes, we're always cleaning up. By the way, I'll be showing the whole node tree in a bit, so if you need to check the settings, you might want to wait. Exit out with tab. Then, rename the node group to Make Body Mesh. Let's unmute the set position and see how the animation looks. Okay, I think it looks decent. As the last portion of this video, I'll add a mouth. Though it's not entirely necessary, it will help the mesh look less like a shell. In the Make Body Mesh group, create some space after the last set position node. Branch a mesh to curve from the set position, Then, from selection, connect the less than or equal. And named attribute bodyFac from A. The opening on the left is extracted. Connect the curve to mesh. Then for profile curve, use curve circle. Resolution of 4 and radius of 0.005 should suffice. Using join geometry, join it with result of set position. Now we have some lips. Okay, let's take a look at what we made. This is the top of the node map. Next is set body movement. Lastly, make body mesh. So we made the mesh and animation for the body. You might be thinking, what a hassle. But considering we made a decent mesh with animation that's within 20 minutes, I think it's efficient work. In the next episode, we'll attach some fins to shape it more into a fish. See you in the next one.